$900. That is where some 48 gigabyte DDR5 kits now appear after selling near $120 last year. The question is why ordinary memory suddenly prices like AI infrastructure. A RAM price spike is not just a shopping annoyance, it is a signal. I paid $120 for a 48 gigabyte DDR5 kit last year. Now, similar capacity can show up at several times that price when stock gets thin. That moves memory from a routine upgrade into a supply chain warning. The first claim is simple. AI is pulling demand away from normal PC buyers. Evidence shows up across the stack. Cloud accelerators need high bandwidth memory, servers need large DRAM pools, and local AI users want more desktop RAM. The reality check is that retail prices move unevenly. One kit can explode while another stays available. Here is the storage and memory math at user level. Quantization shrinks models, but it does not make them tiny. An 8 billion parameter model can fit on a normal machine. A 70 billion parameter model becomes a serious RAM and SSD commitment before it answers one prompt. The next claim is more specific. Inference lives on memory movement. GPUs get the attention, but every generated token depends on moving weights and attention data through fast memory. That is why HBM is strategic for data centers and why system RAM matters when people run models locally. This quick estimate shows why capacity disappears. A 4-bit 70 billion parameter model is about 35 gigabytes before overhead. Add runtime buffers and context, and the safe target moves toward 48 gigabytes or higher. That is the exact capacity band retail buyers are now watching. Fast storage is the second pressure point. NVMe drives hold model files, checkpoints, datasets, generated clips, embeddings, and caches. If RAM is short, the SSD also becomes a spillway. That is not ideal because storage latency is far slower than memory latency, even when the drive is marketed as high-end. Generative media adds another demand source. Image models create thousands of files during iteration. Audio models create stems, drafts, and exports. Video models create the biggest footprint because every experiment becomes frames, previews, and final renders. AI does not only consume storage, it manufactures more things to store. AI coding pushes the same pattern into software teams. The code itself is usually small. The storage growth comes around it. Generated branches, test outputs, containers, build artifacts, logs, and dependency caches. When code gets cheaper to write, the system produces more supporting data around every change. The practical result is hoarding behavior. Companies buy ahead because delays are expensive. Builders buy extra because prices may rise. Labs buy capacity because model work is unpredictable. That behavior can become self-reinforcing. The expectation of scarcity creates more immediate demand, which tightens the market further. The non-obvious buying rule is this: do not buy capacity just because AI is loud. Measure the bottleneck. If your machine swaps while running a model, RAM is the upgrade. If it writes huge caches, checkpoints, or media every day, choose an SSD for sustained speed and endurance, not just the biggest headline number. Here is the catch. It is not accurate to blame every RAM or SSD price jump on AI alone. Memory is cyclical. Suppliers cut and expand production. Phones, laptops, consoles, tariffs, shipping, and retailer inventory all matter. AI is the accelerant, not the only cause. Takeaway: AI is turning RAM and fast storage from commodity upgrades into strategic inventory, and NextToken is watching the bottleneck.